Today we're going to talk about how to solve mass-to-mass problems in a balanced equation. First question you have is, what is a mass-to-mass problem? It's a problem in which you are giving the mass of one of the reactants or products and asked to find the mass of the other product or reactant once it's totally consumed. So here's how we have to do this. There's an actual sequence of events that you must follow, and I'm going to go through it with you. First one is you convert the given mass of the substance to the moles using the molar mass of the substance as a unit factor. Again, when we have a problem, I'll be going through each one of these steps, step by step. 2, convert the moles of the given to the moles of the product or reactant using the mole ratio from the coefficients in the balanced equation. Third, you convert the moles of the specified reactant product to grams. What are the tools you need? You need a periodic table and you need a calculator. Now let's go and try a couple of problems because I think it will become more evident once we try the problems. Here is the balanced equation. Here's the question. How much aluminum is required to react completely with 14.4 grams of iron 2 oxide? Iron 2 oxide, what is that? That is this. Okay, so the first step, we want to convert the grams of iron 2 oxide into moles. What do we have? We have 14.4 grams of iron oxide. How do we get this number? This is the molar mass. We go onto the periodic table, we look up what iron is and what oxygen is, add them together, and that'll give us 71.85 grams. You multiply that by 1 mole, and when that happens, the grams cancel out, and you get moles of iron oxide, which is 0.200 moles. Next step is using the coefficients from the balanced equation, convert the moles of iron oxide to moles of aluminum by applying a mole ratio using coefficients in the balanced equation. What does that mean in English? That means we go to the iron oxide. The coefficient is 3. Then we go to aluminum. The coefficient is 2, if you notice, right there. Okay, so what we now do is take this number, which is 0.20 moles of iron oxide, and we want to cancel that. So we have moles of iron oxide on the bottom and moles of aluminum on the top because that's what we want to produce. How do we get these two numbers? These two numbers come from here. Again, this 3 is here, this 2 is that. And then you get 0.134 moles of aluminum. Now the final step, because we want to now get the answer in grams. Okay, and to do that, we take this number, multiply it by the relationship of 1 mole is what? 26.98 grams of aluminum, and we get 3.60 grams of aluminum. That's how you do this problem. Now, let's go to the next problem. Next problem, excuse me, I'm going to show you similar, but we're going to do it in one full step. Excuse me. The first thing is calculate the mass of potassium iodide to produce 1.78 grams of mercury 2 iodide from equation below. Again, this is the balanced equation. The critical molar masses that we need to know are the ones that are associated with the problem, which means we have to know potassium iodide, which is 166, and we also must know mercury 2 iodide, which is 454.34. Now, instead of going step by step, we're going to try to do this in one step. I call this GMMG. And in this equation, or this sequence, you look at what you have, which is the HgI2, which is this, 1.78 grams. Step 1 is to convert to moles of HgI2. To do that, you need the molar mass, which you have, and then you convert, and these will cancel out, like this. Now, we're going to step 2, which is equivalent to this step right here. And we're going to find the ratio of the moles of Ki to the moles of HgI2. What's that ratio? it's going to be 2 to 1. Once we finish this, we end up with moles of Ki being produced. But they want to know, calculate the mass. They didn't say grams, but that's a fancy word for asking for grams. And if you're not sure on the problem, ask your instructor, because sometimes the problems are vague. So now we go to what a mole of Ki is, which is 166, which we have here. If we don't have it here provided in the problem, we have to again go into the periodic table. We multiply that out and we get 1.30 grams of Ki. And that's how you do what I call mass-to-mass problems. You can do it step by step, or you can do it in one series of steps. It's the same thought process. Some people are more comfortable doing it this way. Some people are more comfortable doing it this way. What I use is this acronym, GMMG.